Let's talk about the counting bits. So you're given an integer n, return the array answer of length n plus 1 such that then there's a number of 1 in the binary representation of I. So in this case, they are supposed to be super simple. And first thing I'm going to talk about a bit operation. So I'm just going to just keep counting the bits for every single integer, right? And then you'll just return the number of the ones inside integer. And the second solution is going to be easier. It's going to be using DP. So if you know, like, here it is. So if you know this is actually a group, this is actually a group. So let me just redraw the diagram again. So this will be a group 0, 1, right? And 2, 3, and 4, 5. So what does this mean? So if you see the power of 2, right? The power of 2 is what? Is 1. The power of 2 is 1, right? Even though the 16, it's still going to be 1. And if there's a power of 2 plus 1, it's going to be what? 1 plus 1 is going to be, because we're remaining the odd number. So this is pretty simple. And here we go. So let me just start recording. So you have result equal to new int n plus 1, right? And then we don't care about the first index, right? So we're starting from I equal to 1, I less than equal to n, and I plus plus. And I'm going to just say result I is also equal to the base at I. So I need to create a public int bit. And I'm passing a num, right? And then I need to return a value. It's supposed to be 0. And I'm going to say, well, num is not equal to 0, right? So time is actually plus equal to what? Plus equal to if the num and 1 is actually equal to 1, right? Then you plus. Then if not, then you're gonna shift your num right by 1, and this will be your counting bits, right? So at the end, I will just return result, right? So this is supposed to be straightforward using the bit operation. Alright, so let's talk about the time and space in this case. Space is going to be all of n. Time is going to be all of n, but you also have another function inside the for loop. This is actually taking what? Taking log n, be honest, because you shift right by 1, and then for every single time is what? Log base 2, right? So it's going to be a log n, right? For the time. Alright. This is not the optimal solution, so here's the optimal solution. So you still want to have a result and new int n plus 1, and it's still converting from 1 to n plus plus. Then I can actually say result equal to result I divided by 2, right? So for the I equal to 1, so I divided by 2 is going to be 0. So these two group, right? So it's going to be what? It's going to be similar, right? But the problem is if I mod 2 is actually an odd number, you need to increment by 1, right? So figure I plus plus. And at the end, just return a result. So, and here we go. And yes, this is a better solution in Diana. So this is what? This is all of n for the space, and this is all of n for the time, right? And without looking the time and space, because you are using the math, you are not using the bit operation. If you're using a bit operation, you can run faster. And this is the solution, and I will see you next time. Bye.